Okay, hello, good evening. My name is Joshua, and I do Advent of Code. Goodness, it's been an interesting year for Advent of Code, mostly because the problems have all been sort of fast twitch problems. To get my fast twitch up, I have installed the Advent of Code data package, which in theory, if everything goes right, I'll just be able to hit that button as soon as the problem drops and get data. I don't know. Anyway, here we go. Yeah, I'm kind of hoping. I haven't decided whether I'm hoping for a quick one tonight or for a less protracted or for a more protracted problem. I think that the last couple of evenings have been really, I think, just too fast, too fast twitch. So, anyway, here comes the problem in 20 seconds. Yeah, da 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 boom boom. Hey, look at that. Oh shit. Fuck. The list of rules is quite long. Make sure you can get it all. Yeah, haha. Okay, let's just parse it first. This actually has potential. Talchus's comment is ew, and that is correct. This is not a lovely problem. Anyway, I'm still writing a parser here. Count, comma, contained equals contains colon match. There we go. Okay, I feel good about that answer. I feel dotted block 0. Oh, sure. Okay, so what I'm going to do here is iterate over all of the bags that I got. And if incol equals... Oh, son of a gun. This is not going to fly. So out color and contents, inner color. If the inner color is the color that we're looking for, then contains, then yes. The outer color can hold the thing we are looking for and iterate. Am I getting this right? Yes. Look for something that can contain the outer color. Iterate on shiny gold. Oh, God damn it. Now, count 0 for KVN pairs of contains. Do count print k. Count equals count plus 1 and print count. Oh shit, that's not right. My parser is wrong. Okay. Well, that was pretty darn close. That's the closest I've got to leaderboarding so far. Shiny gold bag contains... I'm running Linux, Dr. Deceptive. Inner color and n of those return count. Okay. Print tote bags of shiny gold. Yeah, this day is, I think, one of the harder ones so far. This requires actual algorithmic thinking so far. Are required inside my shiny gold bag. So the -1 is correct. It's not an off by 1 error. And now I'm just going to send it. 41559. I'm on the leaderboard finally! Thank God! Oh my goodness. Ah, goodness. 109 out of 42. All right. I feel decent about this. So let's talk about this, Dr. Deceptive. And I have a good friend whose name is 8. That is their name. So I am reticent to say 8 sucks at everything. But let's talk about this. I'm going to bring up my original code here for part 1 here. And there's really two... Let's go back to the problem description. There's really two things that are going on here. There's one, this kind of ugly parsing problem. And boy, just get used to writing ugly parsers for Advent of Code, I guess. In this case, I break this down into 2 steps of parsing. First thing I do is I parse this whole blah contains blah statement, or blah contains no other bag statement. And so I do this in this one parser here. In Lua, minus means anti-greedily match. So match as little as you can while still getting the match correct here. So dot minus bags. So the dot minus means anything up to minus. Okay, now I've got a color. Contain. All right. And then I've got everything except for that trailing. So dot minus, here's another match group. Everything other than that trailing dot here. So now we'll come back up to, we'll look at my sample output. Dotted lavender and, okay, 5 dim plum bags, 1 dull magenta bag. So I've parsed that out there. Welcome if you are a beginner coder. If I'm going too fast, if you'd like me to stop and talk about something else in particular, I am happy to stop and do that. But so this whole problem, this class of problem, where you're trying to take text and split it into its constituent components, that's called parsing. And so that's the kind of thing that you're really going to want to get. And so let's take a look at a earlier night. Let's look at like problem 6 is last night's. And so again, here I have this main loop. Yes, you code in Python, I code in Lua, but the concepts are basically the same. where I read one line at a time. That's still parsing when you're splitting by lines. That counts as parsing. And then I do this funky thing in here for C in line of G match of dot. And that means just iterate through each and every character in that line. And so I'm parsing a line like that. So what I'm doing in terms of parsing here is once I've split it into the first half and the second half, the thing that does the containing, the thing that we are containing inside, now I have to deal with the thing that we're containing inside. And so in Python, which I think you folks are familiar with, you would use a dictionary for this. And so in Lua, everything is either arrays, dictionaries, it's all the same thing. And so here I have, here I initialize this dictionary. I create this bag with an empty dictionary in there. I call it a table in Lua. And I match on so %d plus is please get me as many digits as you can, then as little as you can while still matching, and then a space and bags. And then I want, it turns out that Eric gives you the S, it correctly pluralizes. Okay, so bags and maybe dropping that S there. And so I split this in half here into number of bags and the contained number of bags. How on earth did this work? Okay, well, anyway. So let's see. And so let's talk about, so that's what I was talking about for the first half of part 7 is this parsing problem. And that's really just going to be a fact of life with Advent of Code. Let's talk about this question of how many bag colors can eventually contain at least one shiny gold bag. So what I'm doing here is, I was writing this very quickly, and so I didn't really spend a whole lot of time documenting as I wrote. Clearly not quickly enough to quite get to leaderboard for part 1, but that's life. And so I wrote this function called iter here, and the idea behind iter is it looks for anything that contain one particular bag. And then, once it finds a type of bag that can contain that particular bag, it marks that bag as something that it's seen. So we don't want to multiply count bags or things like that. Here's that. So let's talk through this. We iterate through all of the bags that we have heard of, and I call this the outermost color and the contents. And then we iterate through, now we have one bag and we know what the bag can possibly contain. So we iterate through all of the bags in the innermost color, the things that it can contain. And so if the innermost color, the thing that's inside the bag, is the color that we are looking for, then we mark that in the main list of things that could eventually contain the bag we're looking for. And we start looking for things that could contain the outermost color again, right? So we know that, so if we say that color A could contain color B, could contain shiny gold, then we know that color B could contain shiny gold, and so we mark the color B as a possibility there. And also we have, now we have to go looking for something that can go contain color B. Now that we're looking for something, and so that's that iterative, that recursive step here, iterate color B looking for color A. And so color A can contain color B. And so we go in, iterate, and we hit that also. And so we kick off this iteration process. We start by saying, iterate on shiny gold. And so now we just go walking backwards through, we take one at a time. We go for things that could only contain shiny gold. Then we go look for things that could contain things that could contain shiny gold. Then we look for things that could contain things that could contain things that contain shiny gold, etc., etc., etc. And finally, once we've made a list of all of the colors that could contain shiny gold, and again, we didn't want to duplicate them, so we deduplicated them by putting them in this contains dictionary here. And finally, we just go looking through this whole contains dictionary, and for my sanity, I printed out the ones that we had in there, and that saved me some, that helped when I was debugging that at the beginning, as you could see. We count them all up, we print out that count, and away we go. That's the beginning of part. That's the beginning. That's part 1 for day 7. So, so this is really a fairly classic just search through a tree problem. Let's see. Let's talk about part B. Part B is actually, I think, is easier than part A. It is still a recursive problem, and so we're just going to keep the exact same parser that we had before. So to recap, part 2, the description is they want us to figure out how many things are ultimately contained inside of a single shiny gold bag. And so if I have one shiny gold bag, how many bags are inside? And they very helpfully give us a rule for how to do that. They say 1, and then so each bag counts, right? And then we go look at all of the bags that are inside there, and for each of those bags that are inside there, think about it, again, as a big tree. For each of the bags that's inside, we want to know how many of that color and how many are contained inside of that color. So that's that step there. We accumulate in this variable that I'm calling count here. The n is the number. Remember that we parse that in the parsing step, and we multiply that by the total number of bags that are inside that innermost color. So I'll post the link to the code that I wrote in. And so why is there a -1 here? That's because we don't count the shiny gold bag itself. Bags counts the total number of bags in the whole system entirely. But we don't want to count the outermost shiny gold bag, as Eric apparently doesn't want us to. And so I subtract 1 there. Anyway, so I'll post this in the description. Actually, here, why don't I start off right now by git add 7.lua, 7b.lua, git commit -m7, git push. Cool. I'm just going to go copy and paste the link into GitHub JWise AOC 2020. I'll paste it into the live chat, and I'll stick it all into the description also. Here's the code for tonight. Part 1, part 2. So I've pasted that into the live chat. I just did that over on my other laptop there. And I'm happy to answer questions in the comments also. And so that could be fun for you that are Python programmers to start translating that into Python. And you can start to see how that works. I love Lua. Lua is a great language for prototyping this, but really Python is more useful in the real world. At my day job, I never write Lua. I always write Python at my day job. I'm just fastest typing for Advent of Code in Lua. Anyway, I'm happy to stick around and answer questions if you have them. Otherwise, how am I? That's a reasonable question. I'm tired. I put in a long bike ride yesterday. And I'm still kind of in recovery mode today. But other than that, I am doing well. What is my day job? My day job is I'm half of a little 2-person engineering consultancy. And so if you have work that if you have hardware design and things like that you need done, and software to go with your hardware, then let me know. Accelerated Tech is my business, and I've got a couple. I've got a bunch of projects. I have one project that I'm working on a dash cam right now. Maybe one day later in Advent of Code this season, I'll take you on a tour through my hardware lab. It's not all that exciting, but there's stuff there. But anyway, I have one dash cam project. I've been doing a bunch of iOS system reverse engineering stuff. So that was kind of fun. That's been a fun project. And I am just starting on a 3D sensing project also. So yeah, usually I don't program software. Usually I program hardware. But I don't know. Advent of Code is a fun change. Anyway, so I think that's it for this evening. I'll be back tomorrow night at 9 p.m. and we'll see how well we can do on day 8.